Good morning, everybody. Today I'm going to talk about something a little different, and here's a little clue. I've been working on a little bit different project this past week. I'm taking my family camping, so we need a place to store all the milk. Little kids have to have milk, and of course big dads, they have to have beer. So I've come up with a solution. This is going to be my second attempt. I'm going to be interlacing this video with my previous attempt that I tested out on a previous camping trip, which was wholly inadequate.
So what you're about to see is version 1 of my setup.
Up here, I got a little solar panel, and this solar panel is feeding my car battery, as you can see here. And then the actual battery is charging through this little charge controller. So that's charging the battery. And then I got a little fridge going on here. This is not a good fridge if you want to live off of a battery. There are plenty of fridges that will give you probably double or triple or even like 5 times the performance of this fridge at 60 watts. Yeah, basically this is drawing like at 12 volts. This is drawing like 5 amps.
Now, as you can see, this works on paper. 120 watts at 12 volts, that's 10 amps of incoming current, right? Now, that's 100% efficiency. We got to look at that PWM module for capturing the power, which is probably about 60% efficient at best. So that will give you at best like 6 amps. My fridge is 5 amps. That gives us an amp of power to spare in ideal circumstances. So eventually what I would have in this setup is for the 5 hours when it's drawing 6 amps, when you're sort of charging at 6 amps, I would have a little bit of spare capacity in the car itself. Now, after that, I would use a little battery and use that little battery as my cooler power source for the rest of the day, and then I would just turn off the whole setup at night because no power coming in, and being cooler at night, it's probably gonna just survive as is. That was the idea, and I was wrong.
There is also a little battery here that's also being charged by this system. So the panel is 120 watt, so it's a pretty powerful panel, and I plug it into the Jackery battery, the little tiny battery that I have, the orange and gray one. That's a 240 watt hour. Yeah, so it's a pretty decent battery, but it'll run the little cooler for maybe about 3 hours. The cooler draws about 60 watts, and you want to leave it at about 20%, so you always want to calculate like 3/4. So this morning I decided to just plug in the solar into the car, because the car does have a 50 amp battery, so that makes a lot of sense to me.
Short story, it wasn't a good idea. It drew about 8 amps. I was getting in about maybe 4.5 from the solar panels, and the battery in the car started getting a bit drained. Okay, so let's take a look at version 2. I tried to keep this at the same budget that I had before, so about the cost of the Jackery battery.
Now, this time I might have actually over-designed it. I've got probably about 5 days spare capacity just for the fridge itself, so even if there was no solar, no possibility of charging it through solar for 5 days, we're probably okay, and I can probably just turn up the temperature a bit, because right now it's set up to be pretty low. It's set up to be very, very nice and chill. Okay, so let's move on to the setup itself. I got this solar panel for a previous camping trip. It's 4 30-watt panels, making it 120 watts in total. And yeah, it's pretty good. I was able to probably draw like 4 amps in my previous setup, but that isn't its full potential. I think its full potential will be revealed later when I get a multi-point tracking controller. So yeah, I've got this plugged into my homemade battery bank. As you can see, I've got a little volt gauge. It's also got 2 USB QC30 chargers. I've got a little power button here that I designed for it. Now this power button is not connected. I just designed it but never connected it, unfortunately, because it did mess around with my solar, and the solar does have a controller does have a power button. So this is going to be for future use. Then I have 2 12-volt sockets. As you can see, standard car sockets. One's already plugged in because it's got this fridge plugged in, and we're going to check out the fridge in a few seconds. So basically what I did here is I bought a 20-inch toolbox. So this is $35, right? This guy was about, I don't know, 10 bucks. These two were, again, like maybe 10 bucks. Switches, I don't even count that as cost. You know, maybe 30 cents because I bought a bag of them for my other projects. So what we have in here is we've got an AGM battery. So this is 105 amp hours. It's a Nautilus Moto Master. You get it at Canadian Tire here in Canada, but it's made down in the US. It's a, I don't know the name of the company that makes it, but it's a pretty high quality AGM battery. This guy runs at about 370 bucks. And at 105 amp hours, I'm probably going to be able to pull 50 amp hours easily out of it, which means plenty of energy storage. It's not very lightweight. This is group 31, and group 31 batteries are pretty heavy. I just cut out this the top of the box, as you can see, is just cut out so that it fits the battery. I got a spare extension cable with MC4 connectors. I got some spare stuff for my MC4. I got some stuff to repair things if needed, right? And then I screwed on this controller. I got this with the batteries, I got this with a solar panel. It's a PWM controller, so it's not very efficient, but it's yeah, it's 9:45 in the morning right now on a sunny day, and we can see that at 9:45 in the morning I'm getting 2.5 amps in to the battery itself. Now I've never gotten over 3.5 amps with this controller itself, even like very at very like noon, but that could be because the battery has never really been discharged that much. I was testing out the fridge and I got it down to 24 volts. Right now it's showing, like, you know, the last quarter percentage is up. So this battery goes up to 12.7 when it's full. I got it down to 12.4 with basically overnight, a whole day, and then another overnight. So what would that be, like about 36 hours of running this fridge, 3-volt drop, and yeah, that's it. So yeah, here I have a I think this is a 12 gauge wire. No, it's a 14 gauge probably. No, it's a 12 gauge wire. Yeah, 12 gauge wire going into the battery, positive and negative, going to the controller. There's a spare because this is just the standard, you know, electrical wire. I got the battery outs coming here and underneath and going into this, right? There's a little fuse, of course, as there is supposed to be, a little 10 amp fuse there. And negative and positive leads go to. They used to go to this one, they used to go to the switch, but you know, this thing does have a switch on it, so I can turn it off and on here, as you can see with this light thing, right? And you heard the switch, you heard the fridge go beep. So yeah, and then there's the two sockets. I mean, there's plenty of space to add more stuff if I need to, and this thing does have capacity. Now, one thing I'm going to add in here somewhere is a charge controller, so I can plug it into 120 volt. I've got the charge controller on the way. I ordered it, but it's not. It doesn't come yet. It didn't come yet. And the other thing I'm going to do is I'm going to replace this cheap PWM controller with a MPPT, so that I get a little bit more efficiency off of that solar panel, because you got a 120 watt solar panel. You don't want to just be pulling 3 amps at 12 volts, which is, you know, not a lot, 40 watts. I want to be pulling in, you know, at peak sunlight, I want to be pulling in much more than that. But of course, that will only happen if this battery does get drained, and this battery is going to have a difficult time getting drained if I keep charging it. So it's a good thing, right? I think this controller would work, but I want the other one because it does have Bluetooth, and it does have energy history. So you can upload energy history, which is cool. But that's what it is. It's cool. All right, let's call this guy up. And this is what I have plugged in here. It's a fridge. Basically it's a compressor fridge, right? It's not thermoelectric. I previously had a thermoelectric, but it just drew 5 amps constantly. And if I just draw 5 amps constantly, I'm just gonna kill that battery in, you know, 2 days. So this one actually draws about 3.5 amps when it's operating, goes up to 4 amps at some point in time. And then it just sits there because it's compressor based.
So the way the thermoelectric fridge works is it runs continuously. You have the Peltier element that just needs electricity continuously to stay cold. The way a compressor fridge works is it just runs the compressor and then turns it off, and then runs it again and turns it off. That means that you're using a lot less power over time. The cooler drew about 5 amps continuously. This guy draws about 4 amps for 5 minutes, and then it turns off about 5 to 10 minutes, depending on the temperature outside. So even if we're looking 5 minutes and 5 minutes, that's only 30 minutes every hour at 4 amps. So that's 2 amp hours versus 5 amp hours over time, right? And I can easily get 2 amp hours in. You saw that it was the solar was giving me 2.5 amp hours at 9:30 in the morning. And of course, if we calculate that to 50 amp hours, even if there was no solar going in at 2 amp hours, I have at least 2 days, if not more. Probably more than 2 days of capacity, because when I was running it for 2 days overnight, it barely ran. Worst case scenario, it's 2 days. But in reality, probably 5 days of running capacity on just this fridge alone.
It's saying 3 degrees Celsius right now. I got this, let's just reset it just to see if it's showing correctly. Yeah, 3 degrees. So it's pretty accurate as far as the temperature is concerned. It does go down, up and down quite a lot. So it does go like to 1 and then up to 6 and 1 and 6 and 1 and 6. But that's just measuring the temperature of the actual wall where the where the sensor is for this guy, right? This guy also tells me about voltage. It's seeing 12.8, 12.9 right now, which is normal. That's what you should be seeing. This one's saying 13.2 because it's a little bit off. But if we look at the charge controller is going to say 13 volts. Yeah, so I do get a loss of a volt, probably because of the length of 0.1 of a volt, because of the length of this cable, because it's quite long. And DC, you know, and lengths of cables, no good. And of course, this guy's got it's got quite a lot of room in it. As you can see, I got some refreshments already in there. And of course, I already broke this little retainer chain Because, you know, it is what it is. It just happens as soon as I like let go of the thing for the first time. It just broke, of course. And I'm going to replace this with a little rope design, a little nylon rope. I'll just take the chain out right here, and I'll put a little nylon rope to hold it together. But yeah, this is the setup. So I think that we can survive a 10-day trip even if we don't have much solar coming in. We probably will have enough solar coming in to top up the battery every day. Otherwise, the camping trip ain't gonna be much fun, is it? If you have a camping trip and you're just like sitting in the tent, it's not fun. I hope you liked this video. It's a bit different. It's not what I usually do, but I wanted to show you what I was working on this past week. So this whole setup, if we look at the battery itself, the setup itself for the battery, to figure it out and build it was about 6 hours. I know that's a lot of time, but you know, you make mistakes, and I had to learn how to do the MC4 connectors, and you know, it is what it is. Anyway, I hope you liked this video, and of course, if you like my channel, please consider subscribing. Thank you. Bye.